NASA's internal models are predicting a direct impact, and if they are right, Canada's grid collapses. Right now, over 38 million people live and work in a country uniquely vulnerable to an attack from the sun. They depend on an electrical system that stretches thousands of kilometers across some of the most unforgiving geology on the planet. One coronal mass ejection, and that entire system fails. For weeks. The models have been running for months. The data points consistently to one terrifying outcome. By 2025, Earth is projected to cross paths with a solar storm of a magnitude not seen in decades. And for Canada, this is not a question of flickering lights or a regional brownout. This is a scenario that ends in total darkness. Not for a few hours, for weeks, maybe longer. So, the government did what it always does. It commissioned studies, held meetings, and issued quiet advisories. They hardened key substations. They put spare transformers on standby. It should have been enough preparation. But here is the part nobody is telling you. The ground beneath Canada is not an insulator. It's a conductor. The rock itself will become an antenna for the storm, channeling destructive energy directly into the heart of the grid. The uncomfortable question is, did NASA just give Canada a warning? Or did it just deliver a death sentence to the modern world as we know it north of the border? The science of this is both elegant and brutal. Our sun is not a steady, gentle star. It is a chaotic, violent nuclear furnace that periodically throws tantrums. These tantrums eject billions of tons of magnetized plasma into space, a phenomenon scientists call a coronal mass ejection, or CME. Most of them miss. They fly harmlessly into the vacuum of the solar system. But sometimes, one lines up perfectly with Earth. When that happens, our planet's magnetic field, our magnetosphere, is hit by a tsunami of charged particles. It's an impact you cannot see, you cannot hear, and you cannot feel. But our infrastructure can. The entire electrical grid, the vast global network of wires and transformers we built to power our civilization, acts as a single, continent-spanning antenna. The fluctuating magnetic field from the solar storm induces powerful, uncontrolled currents in these long transmission lines. Geomagnetically induced currents. GICs, that is the technical term. The reality is simpler. It's alien electricity, rogue current flooding into a system that was never designed to handle it. Now, we have thousands of viewers watching these reports. And many don't realize that our mission relies on your support. If you believe this information is critical, you need to subscribe. This isn't just entertainment. It's an essential briefing on risks that are rarely discussed. Hit that subscribe button now, so you are not left in the dark. Let's begin. This rogue current flows into the massive transformers at the heart of our electrical substations. These transformers are the workhorses of the grid, stepping voltage up or down for transmission. They are precision-engineered, billion-dollar assets. And the GICs cook them from the inside out. The direct current component of the GIC effectively blinds the transformer, causing its magnetic core to saturate. It overheats, violently. The copper windings that took months to install can melt in minutes. The insulating oil can flash into explosive gas. A piece of infrastructure that weighs 400 tons that took 2 years to build and transport can be destroyed in less time than it takes to watch a movie. That is the mechanism of failure. Not a software glitch, not a cyber attack. A physical, irreversible act of destruction caused by our own star. And Canada is uniquely, terrifyingly susceptible. Why? 2 reasons: geology and geography. First, geography. Canada is the second largest country on Earth. Its population centers in the south are powered by massive hydroelectric projects in the far north. Think of the James Bay Project in Quebec or the projects in Labrador and northern Manitoba. These power stations are thousands of kilometers away from cities like Toronto, Montreal, and Ottawa. To connect them, engineers built some of the longest high-voltage transmission lines in the world, lines that stretch over vast empty wilderness. Those lines, by their very length, are exceptionally efficient at picking up geomagnetically induced currents. They are magnets for the storm's energy. But the second reason, is the real killer: the geology. A huge portion of eastern and central Canada sits on top of the Canadian Shield. The Canadian Shield is a vast expanse of exposed Precambrian igneous rock, some of the oldest, hardest rock on Earth. This ancient bedrock is highly resistive. It does not absorb electrical current well. So when charged particles from a solar storm hit the ground, the current doesn't dissipate into the Earth. Instead, it seeks the path of least resistance. And what is that path? The man-made network of buried pipes and grounded electrical transmission lines. The ground itself, the very foundation of the country, funnels this destructive energy directly into the grid's most vulnerable points. The Canadian Shield doesn't protect the grid, it weaponizes the storm against it. It's a perfect storm of vulnerabilities: long wires acting as antennas, ancient resistive rock acting as a channel, and at the end of that channel, transformers that will be pushed to their breaking point. We are watching a disaster unfold in slow motion, written in the language of physics and geology. If you're just grasping the scale of this vulnerability, let us know in the comments what part of this science is the most unsettling to you. We read all of them. This is not a theoretical problem. This is not a climate model projection for 50 years from now. This happened before. March 13th, 1989, a solar storm, powerful but by no means a historic monster, slammed into Earth's magnetic field. Around the world, shortwave radio signals failed. The northern lights, the aurora, were seen as far south as Texas and Cuba. But in Quebec, something else happened. At 2:44 am, geomagnetically induced currents began surging through Hydro-Quebec's long transmission lines from James Bay. The system's protective relays, designed to trip during overloads, began to see phantom signals. Wild voltage swings that made no sense. Within 90 seconds, the entire grid collapsed. Not a section, the entire thing. 6 million people were plunged into total darkness. Montreal's metro system stopped dead in its tunnels. The airport went dark. Businesses, homes, hospitals, silence. For 9 hours, one of North America's most advanced provinces was functionally knocked back to the 19th century by a storm that was considered moderate. The 1989 Quebec event was a wake-up call, a terrifying, costly, and deeply embarrassing one. Hydro-Quebec spent over $1 billion hardening its system in the aftermath. They installed series capacitors on their long transmission lines. They developed new protective relays that could distinguish between a GIC and a typical system fault. They created a real-time space weather monitoring center. They did everything right. They studied the last war and built the perfect defense against it. They solved the 1989 problem. And it still will not be enough. The storm that NASA is warning about is not the 1989 storm. The models predict an event on the scale of the Carrington event of 1859. That was the largest solar storm in recorded history. It was a monster. Back then, the world's most advanced electrical infrastructure was the telegraph system. When the Carrington storm hit, telegraph lines around the world spontaneously shorted out. Operators were electrocuted. Telegraph paper burst into flames. The induced currents were so strong that some operators disconnected their batteries and continued sending messages using only the energy from the solar storm itself. Now, imagine an event of that magnitude hitting our modern world. A world not of simple telegraph wires, but of interconnected grids, satellites, and digital everything. This isn't a theory. This is a historical precedent. If this story is opening your eyes to a real-world threat you never considered, do us a favor and like this video. And share it with your family. This is information everyone needs to understand, because it affects everyone. A Carrington-class event would induce currents not just for a few minutes, like in 1989, but for hours. The GICs would be an order of magnitude stronger. The defenses that Hydro-Quebec built, the series capacitors and blocking devices, are designed for the GICs seen in a moderate storm. They are not designed to withstand the sustained, overwhelming deluge of a generational solar event. They would be saturated. Overwhelmed, bypassed, the system would fail. But this time, it wouldn't just be the relays tripping. It would be the transformers themselves physically burning out. And this is where the timeline shifts from hours to weeks. Or months. A circuit breaker can be reset in minutes. A destroyed transformer cannot. These are not devices you can buy at a hardware store. A large, high-voltage transformer is a bespoke piece of equipment. It weighs as much as a jumbo jet. It has to be custom designed for its specific place in the grid. The lead time to build a new one is, on average, 12 to 24 months. And that's in a normal world. Imagine a world where dozens of these transformers across Canada and the northern United States are destroyed simultaneously. There is no stockpile. There is no factory ready to mass produce them. The handful of spare units kept in storage would be used up immediately. Then what? You are waiting for a supply chain that itself requires electricity to function. You are waiting for manufacturing plants that are dark. You are waiting for transportation networks, rail, shipping that are crippled. A 2013 study from Lloyd's of London modeled the effect of a Carrington-class event on the North American grid. Their findings were conservative, and they were still apocalyptic. They estimated that 20 to 40 million people in the U.S. alone could be without power for up to 2 years. The total economic cost would be in the trillions of dollars. It wasn't the initial outage that was the issue. It was the recovery. The sheer impossible logistics of rebuilding the backbone of a continent's electrical supply from scratch. What does weeks of darkness actually look like in a country like Canada, especially in winter? The silence would be the first thing. The constant hum of modern life, refrigerators, ventilation systems, traffic, gone. Then the cold begins to creep in. Most modern heating systems, whether natural gas, oil, or electric, require electricity to run their circulation pumps and electronic ignition. No power means no heat. For millions living in a climate where temperatures can drop to 30 below zero, a home quickly becomes a freezer. Water stops flowing. Municipal water systems rely on electric pumps to maintain pressure and move water from treatment plants to homes. No electricity means no water pressure. Taps run dry. Toilets don't flush. Fire hydrants become useless. Suddenly, a city of millions has a medieval-era problem, finding clean, drinkable water and dealing with sanitation. Communication collapses. Cell towers have backup batteries, but they only last for hours, not days. After that, silence, no internet, no phones. No way to call for help or receive information. The isolation would be total. The supply chain freezes. Grocery stores are cleared out within a day. Then they are not restocked. The entire just-in-time delivery system for food, medicine, and fuel relies on electricity at every single step, from the warehouse to the refrigerated trucks to the point of sale terminals. Without power, it all grinds to a halt. Hospitals, which have backup generators, become islands in a sea of darkness. But their fuel is finite. Once it runs out, their life-saving equipment goes silent. A functioning hospital becomes a collection of buildings. This is the cascading failure that keeps engineers and emergency planners awake at night. The initial problem, the power outage, triggers a dozen other interconnected crises, each one compounding the last. It is not one disaster. It is all of them at once. It is a systems collapse. Just a quick reminder, if you're finding this analysis valuable, please take a moment to subscribe. We are a small team, and it's the single best way to ensure you get our next briefing and helps us continue to produce this work. It makes a huge difference. So what is being done? Is anyone listening to the warnings from NASA? The answer is yes, but the scale of the problem is monumental. The Canadian government, along with its American counterparts, has been slowly, quietly trying to prepare. Projects are underway to create strategic transformer reserves, a national stockpile of these critical components. But the number of spares is a tiny fraction of what would be needed in a widespread event. Scientists at Natural Resources Canada run the Canadian Space Weather Forecast Centre. They monitor the sun 24/7 using satellite data to provide warnings of incoming storms. Their models can now give about 18 to 24 hours of notice before a CME hits Earth. That is enough time to put the grid into a protective configuration, to take sensitive equipment offline, and to warn operators to brace for impact. It is not enough time to prevent the damage from a truly massive storm. It is a forecast, not a force field. There is also a push towards building smaller, decentralized microgrids. A university campus, a hospital complex, or a small town could have its own local power source, solar, batteries, natural gas generation that could disconnect from the main grid during a crisis and operate independently. It is a brilliant, resilient strategy. It is also incredibly expensive and will take decades to implement on a national scale. Right now, these microgrids are the exception, not the rule. The vast majority of the population remains completely dependent on the large, vulnerable, interconnected system. I know, this might be the second time I'm asking, but our subscriber numbers are low compared to how many of you watch these deep dives. It's genuinely the best way to support this channel and our mission to get this critical information out there for free. So if you haven't already, please consider hitting that subscribe button. It's a small click for you, but it's the lifeblood for us. Now, back to the potential freezing darkness. The deepest, most unsettling part of this entire problem is the sun itself. We are currently in solar cycle 25. Every 11 years, the sun's magnetic activity waxes and wanes. Solar cycle 24, which ended in 2019, was the weakest in a century. We got complacent. Solar cycle 25 is proving to be much more active. It is expected to peak in mid-2025, and it is already producing significant flares in CMEs with alarming frequency. The odds of a direct, Earth-facing Carrington-class event are not static. They are increasing with every rotation of the sun. We are entering the most dangerous part of the cycle. The threat is not just from a single, massive storm. A new theory gaining traction among solar scientists is the danger of multiple successive storms. Imagine a scenario where a moderate storm hits, weakening the grid and taking a few transformers offline. The system is stressed but holding. Then, 2 or 3 days later, before recovery is even possible, a second storm hits. This 1-2 punch could be far more devastating than a single, larger blow. It would be a war of attrition against our infrastructure, and the sun has limitless reserves. We built a planetary civilization on a foundation of cheap, reliable electricity. We took it for granted. We assumed the network that powers our lives was robust, permanent. We built it to withstand ice storms, hurricanes, and earthquakes. We never truly built it to withstand the star that sits at the center of our solar system. The very source of all life on Earth is also, potentially, the source of our civilization's undoing. Think of the irony. For decades, our greatest existential threat felt man-made. Nuclear war, climate change, a global pandemic, all consequences of our own actions. But this threat is different. It is ancient. It is cosmic. It is completely indifferent to us. The sun does not care about our satellites, our internet, or our power grid. It has been producing these storms for billions of years before we existed, and it will continue to do so long after we are gone. We just happen to build a fragile, technologically dependent society in the direct line of fire. The engineers at Hydro-Quebec and other utilities know this. The scientists at NASA and NRCan know this. They are working on the problem. They are brilliant, dedicated people. But they are fighting a battle against physics and economics. Hardening the entire North American power grid to be truly resilient against a Carrington-class event would cost trillions of dollars and take decades of coordinated international effort. It would be the largest infrastructure project in human history. And we are running out of time. The sun is not waiting for our budget cycles or our political debates. The peak of solar cycle 25 is coming. What does this mean for you? It means understanding the fragility of the systems we depend on. It means having a plan, not a doomsday prepper bunker, but a practical, common-sense plan. Weeks of food and water, a non-electric heat source if you live in a cold climate, a battery-powered or hand-crank radio to receive information. The basic preparations our grandparents would have considered normal are now life-saving strategies in the face of a 21st century threat. The third straw in the Las Vegas story was a $1.4 billion engineering solution to a problem of scarcity. This is different. There is no tunnel we can drill to escape the sun. There is no single piece of technology that can solve this. The solution is resilience, which is slower, less glamorous, and far more complex. It's about building a society that can withstand a shock, that can function when the master switch is thrown to off. One last time, if you want to stay ahead of stories that directly impact our world, subscribing is absolutely critical. It ensures you won't miss our next report. Thank you for your support. In the end, this isn't a story about Canada. It's a story about the modern world. Canada's unique geology and geography just make it the canary in the coal mine. The first to feel the effects of a danger that threatens every high-latitude country on Earth, from the United States to Scandinavia to Russia. The interconnectedness that gives our grid its strength is also its greatest weakness. A failure in Quebec could cascade into New England. A failure in Manitoba could black out the Midwest. We are all tied together on this planetary-scale electrical machine. The warning from NASA is not an academic exercise. It is a ticking clock. The sun is ramping up, the models are pointing to a direct hit, and our defenses are designed for a war we fought 30 years ago. The question is no longer if a civilization-altering solar storm will happen. The question is when.